In the previous lesson, we've learned about proportions, rates and ratios, and how to find one of their terms. Now we're going to apply that in word problems. In this lesson, we're going to learn about direct versus inverse proportionality. I thought of giving you two examples, two word problems, and let's see how they're different. The first question is, the recipe of a cake requires 3 cups of flour and 2 cups of water. By mistake, instead of 3 cups of flour, I put 4. How many cups of water should I use to keep the proportions? Okay, so imagine that. Now the second question, second problem. John can build a new garage in 3 days. If his friend Tom helps him, working at the same rate, how long will it take them both to finish the garage? As you can see, I just chose some random numbers. You can do them in your mind, but it's not possible all the time to solve the word problems in your head. So let's see how we can do that. First of all, we're going to start by looking at the question, and we know that it's about flour and water. Let's put the data in here to use it, obviously. We have 3 cups of flour and 2 of water. I wrote flour and water here because it's absolutely mandatory that no matter what, you have to organize your data such that when you're talking about flour, it should be in this column on to the left of the column here. And when you're talking about water, it should be in this column. This is what we know, okay? Now let's see what we don't, or what we can find based on the data we have. We have 4 cups of flour instead of 3. And how many cups of water should I put in here? So as you can see, water is all the time here and flour here. You don't necessarily have to write flour and water, just pay attention to it. Now, if you're thinking a little bit, just tell me. So I put more flour here, right? Do you think I should put more or less water? The same thing here in the second question. We have people and days. I said people. John can build a new garage in 3 days. So this is what we know. We're going to write that this way. One person, John, one person, can build the garage in 3 days. So pay attention, days on the days. So this is what we know. If his friend Tom helps him, they're going to be 2 people, right? Working at the same rate. How long will it take them both to finish the garage? So 2 people. How long, how many days will it take them to finish the garage? What do you think? Here there are 2 people, meaning more than one, so more than it was before. Do you think they're going to need more or less days here to finish the garage? Let's get back to the first question. I put more cups of flour. Do you think I need more or less cups of water? If you chose more, that's the right answer. More cups of flour in my case need more cups of water. So it's the same correspondence here. This is called direct proportionality. And here, more people to do the same job will take more or less time. What did you say? If you said less time, you were right. More people to do the same job will take less time. This is inverse. It's not the same. It's not more or less. It's more and less. So this is an inverse proportionality. The way we're going to solve them both is similar, using proportions. This one is a direct proportionality. We're going to write 3 over 4 equals 2 over x. And here is your proportion. And obviously from here you solve it the same way I taught you x equals the product of the means, 2 times 4 over 3. And then you do the solution, so 4 times 2 over 3, 8 over 3, 2 and 1 over 3. What does that mean? X was water. I need 2 cups of water and 1/3. Here, more or less, so it's not the same. It's not less people, less days, or more people, more days. It's one of them is more, the other one is less, or it could have been the other way around. Obviously, the less people we have, the longer it's going to take. So it's an inverse proportionality. In this case, when you write the proportion, you're going to write 1 over 2 equals, and you write the inverse of the other one. Do not try to write both of them as an inverse, because it will still not make any difference from the previous case. Only one of them should be inverse, okay? And from here, obviously, you're going to solve them the same way we've learned. X equals 1 times 3 over 2. 3 over 2 equals 1 and 1 over 2. That was X. What was X? Number of days. So they will need 1 day and a half to finish the job. Don't forget to state what you're saying. Now I have an application for you. You solve it. At the movie theater, 90 student tickets were sold for 1 show. The ratio of adult tickets sold to students' tickets sold was 4 to 7. How many adult tickets were sold? Here you pause the video and solve it. After that, you're going to see the solution. Assuming you solved it, here's the solution. It's about tickets sold for adults and students. So adults and students. 98 student tickets were sold for 1 show. So where would I put 98? For under the student here. So 98. The ratio of adult tickets sold to students' tickets sold was 4 to 7. So that's one thing that I know. So 4 to 7. How many adult tickets were sold? So adult tickets, how many are sold here? If they sold 98 for students. Here, 98 tickets are more than 7. Do you think they're going to be sold more or less adult tickets? Your answer is more. So more, that's a direct proportionality. We can write the proportion, x over 4 equals 98 over 7. And you find x from here, or you can just imagine that you have that proportion here, and you can say, and you can find x directly. But I'm going to find it from here because I wrote it. So x equals fraction line. What goes underneath? 7. And on the top, the other 2, 4 times 98. Let's try to simplify 7 and 98 by 7. So 7 divided by 7 is 1. 98 divided by 7 is 1, 4. X equals 4 times 14, 56. Hence, 56 adult tickets were sold. Now, let's check some applications. Applications, we have them everywhere. I just chose some at random, the most common ones that you're going to encounter. So one of them is going to be unit rates. A unit rate means something per, because it's a unit rate, it's a rate, 1 unit of something else. So whatever per 1 unit of something else, that's a unit rate. That's where the unit word comes from, because it's one of the terms here, it's 1. You can think of 40 kilometers per 1 hour. We always say it's 40 kilometers per hour, but it's per 1 hour. Or $4 per kilogram, per 1 kilogram. So this is a unit rate. An example would be 12 bottles of juice can be bought for $5.99. How much does one bottle cost? Let's solve it. It's about bottles and dollars, right? 12 bottles of juice can be bought for $5.99. How much does one bottle? So one bottle, so it's about bottles. I'm going to put it under the bottle here. One. How much does it cost? It's about dollars. I'm going to put it here. Obviously, less bottles, it's 1 compared to 12 is less, will cost more or less money. Less money. It's a direct proportionality. The proportion would be 12 over 1 equals 5.99 over x. Hence, x equals fraction line. Which one goes underneath? X and 12. So 12 goes underneath. 1 times 5.99. And you use a calculator to compute it and see how much that is. So it's 5.99 divided by 12. If I round it to 6 divided by 12, it would be 0.50 cents, about 0.50 cents each. Another application would be speed. That's very common. Kilometers per hour. Remember, you're going to divide the distance by the time. Or it could be meters per second or miles per hour. Example, John drove 550 kilometers from his house to his grandparents in 6 hours. What was his average speed? Let's solve it. Why do we say average? Because maybe John stopped on his way to his grandparents' house. But let's see, it's about kilometers in this question and hours. Kilometers and hours. 550 kilometers in 6 hours. Remember? Kilometers under kilometers, hours under hours. What was his average speed? So how many kilometers per hour in a 1 hour? 1 here. How many kilometers? We don't know x. Obviously in 1 hour, in less hours, he drove a shorter distance. X equals, so it's a direct proportionality. Less time, less kilometers. X equals, which one is? It's 6 here. 550 times 1 on the top. And again, you can just use a calculator or solve it approximately. 6 goes into 55 9 times, into 10 1 time, approximately 91 point something kilometers per hour. Another application would be conversions from metric system to imperial or fractions to percent. That's what we're going to learn in our next lesson, fractions to percent. An example would be, how many feet are there in 5 meters? Let's solve it. It's about feet, right? And meters. We know that 1 meter has 3.3 approximately feet. In 5 meters, so where would I put the 5? Under the meter, so under the 1 in fact. We have how many feet? We don't know, x. Obviously, more meters, more feet. So it's a larger distance. X would equal fraction line. X goes into, the 1 goes underneath. And on the top, 3.3 times 5. X equals 16.5. What was x? Feet. So 16.5 feet. Another application would be scales. This is probably the last one because there are too many to mention here. For example, you have a chart. I took this from Google And if you're looking here, it says that 5 kilometers represent that distance. How many, let's say, how many kilometers from Blackstock, from here, to Birketon station, from to here? All you have to do is to measure this distance using a ruler, and let's see how we solve it after that. So you take a ruler, you measure the distance from Blackstock to Birketon station, and I don't know, maybe on your map it might be, so on my map it might be about 2 or 3 centimeters. So I'll round it to 3 centimeters. And all we have to do is to write here, what do we have? We have kilometers and centimeters, right? So the distance on reality and the distance on the map and real. On the map, it says that 5 kilometers represent that distance. I would approximate it to 1.5 centimeters. It says 5 kilometers, so kilometers here, represent on our map, and usually it says in numbers or something, but here you need to measure that, 1.5 centimeters on my map. And when I measure the distance from here to here, I would say 2 centimeters on the map. How many kilometers? Obviously the same. The longer the distance on the map, the longer in reality. So it's the same direct proportionality. Hence, x equals fraction line. Which one is it? 1.5 underneath. 2 times 5 on the top. 2 times 5. So 10 over 15. 1.5. Round it, or multiply by 10, 100 over 15, divided by 5, 20 over 3, that's 66.7. What was x? X is kilometers, so 6.7 is kilometers. That's the real distance from here to here. I just made it up. Now that's our lesson. I hope you are going to be able to solve all of the questions that I'm going to assign to you. Have fun.